All right, let's get started with chapter 6. 6.1, angles, degrees, and triangles. So a good deal of this is going to be review from geometry. So let's just throw a few vocab phrases in there for us. The point where two lines meet to form an angle is called the vertex. When we rotate, if we are spinning in a counterclockwise direction, that's going to be a positive angle. The initial side rotates towards the terminal side, terminal meaning the end. And if we rotate down or in a clockwise direction, we're going to have a negative angle. All right, a full circle makes a complete revolution of 360 degrees. And then I think we know these things. A 90-degree angle is a right angle. A straight line is 180 degrees. Acute angles are between 0 and 90, and obtuse angles are between 90 and 180. Hopefully that rings a few bells from last year in geometry. Okay, complements. Complementary angles add up to 90. Supplementary angles add up to 180. So let's try a few problems. Find the complement of 50. We could say 50 plus its complement, x equals 90. So x, the complement, is 40 degrees. And the supplementary angles add up to 180 degrees. So in this case, x would be 70 degrees, the supplementary angle. All right, can we represent the complement of alpha in terms of alpha? So alpha plus its complement equals 90 degrees. So the complement equals 90 degrees minus alpha. And then lastly, let's find two supplementary angles, angle 1 and angle 2. Supplementary add up to 180, where the first angle is twice as much as the second angle. So we would say that 3x equals 180, x equals 60. So angle 1 would be 120, and angle 2 would be 60 degrees. All right, your turn. Give it a shot. All right, so angle 1 plus angle 2, they are supplementary, so adds up to 180. The first angle is 3 times as large as the second angle. 4x will equal 180, which means that x equals 45 degrees. So the first angle is 3 times that, 135 degrees. Angle 2 is 45 degrees. On we go. All right. The three angles in a triangle, their measure adds up to 180 degrees. So if we have 32 degrees and 68 degrees for two angles, we add those together, we end up with 100 degrees, which means that the last angle must be 80 degrees. Your turn. All right, 16 plus 96 is 112 degrees, which means that the remaining angle is 68 degrees. Okay, Pythagorean, a squared plus b squared equals c squared. We should have done this in geometry. So if we have a 10-foot ladder and that's leaning against an 8-foot house, how far away from the house is the base of the ladder? X squared plus 8 squared equals 8 squared. X squared equals 100 minus 64, which is 36. So what does x equal? X equals 6 feet. Not plus or minus because you can't have a negative distance here. Your turn. All right, we're building a skateboard ramp. The height of the ramp is 9. The horizontal grand distance is 12. What is our hypotenuse? 9 squared plus 12 squared equals h squared. 81 plus 144 is 225. So our hypotenuse is 15. All right, let's do this with radicals. So in this case, we're going to say 3 squared plus x squared equals 7 squared. So we're going to have x squared equals 49 minus 9, which is 40. Square root both sides, and we do not want to come up with a decimal. We want the exact answer. So the square root of 40 breaks down into the square root of 4, square root of 10. So x here is 2 rad 10. So with our radicals, always break them down using perfect squares. Your turn. So you should have 8 squared equals 4 squared plus x squared. 64 equals 16 plus squared. That is 48 equals x squared. And that is 16 and 3 equals x. This is for rad 3 for your x value. Okay, big thing in this chapter, we need to know about our 45, 45, 90 triangles. They will have these relationships. The legs are x, the length of the hypotenuse is rad 2 times x. And then we have a 30, 60, 90 triangle. Special values, the short side is x, the medium side, the longer leg is rad 3x, and the hypotenuse will always be twice the short side. So let's solve this. We have a perfect right triangle with x and 60. This is a 45, 45, 90. So what does x equal? So remember our ratios back here for 45, 45, 90 was 1 to rad 2 for our short to long. You could say it like this: leg over hypotenuse always needs to be the same. So the ratio is 1 over rad 2 is the same as, in this case, our leg is x and our hypotenuse is 60. So in this case, we're going to say cross multiply rad 2x equals 60. X equals 60 divided by rad 2. We got to rationalize our denominator. We would have 60 rad 2 over 2. So x is 30 rad 2. It does say round to the nearest foot here, so we can plug that into our calculator, but this would be the exact answer. All right, let's do this with an exact answer also. See if you can do it. All right, the sides of the roof are 60 feet each. How wide is the house? If this is a 45-degree pitch, 90-degree top, then this one is actually pretty easy because the hypotenuse is just going to be add on a rad 2. All right, our 30, 60, 90 triangle here, we've got 15 feet in our tree, and we've got 30 as the top angle here, 60 here. So 15 is the medium length, and our job is to figure out how much rope we're going to use. So we want to figure out our hypotenuse. All right, in our 30, 60, 90, remember that our ratios are x, rad 3x, and 2x. So our ratio here is rad 3 over 2 equals 15 over h. So rad 3h equals 30. H equals 30 over rad 3. Let's rationalize our denominator. We get 30 rad 3 over 3. So our hypotenuse is 10 rad 3. Now, in this case, there is rope on both sides of the tree. So it would be 10 rad 3 plus another 10 rad 3, 2 ropes to get ourselves 20 rad 3 feet of rope. All right, your turn. Redo this. So the height is 20 feet. You'd have 20 and h. Again, we're going to say rad 3 over 2 is equal to 20 over h. So rad 3h equals 40. And we'll divide both sides by rad 3. And then rationalize this denominator. So your height will be 40 rad 3 over 3. And the total rope will be twice that. So we're going to have 80 rad 3 over 3 feet. Okay, lastly, we'll talk about similar triangles in this chapter. Similar triangles, we've actually been doing that here with our similar triangles, with 20 and h matching up with rad 3 and 2. In our similar triangles, the corresponding sides have a proportional length. So let's just try an example. In this problem, 2 and 8 are proportional, so is 5 and b. So we can say 2 over 8 is equal to 5 over b. And so 2b equals 40, and b equals 20, 4 times as much. That makes sense. 2 times 4 is 8. 5 times 4 is 20. We can do the same thing here. 6 times 4 is going to get us 24 for C. Your turn. All right, so in this case, we're going to say 9 matches up with the 27. So we're multiplying by 3 to go from here to here. And so that means that A would be 5 and B would be 8. Let's do one more example with the height of a tree. We have a common ratio here. The tree height versus we put a ruler up and measure the shadow. So we're going to say 3 over 1.75 is proportional to x feet of our tree over 19. So we'll cross multiply. 19 times 3 is 57 equals 1.75x. And so we're going to put that in our calculator. Let's go ahead and grab that. So 57 divided by 1.75 is equal to 32.57. And it does say, oh no, this one says, do we want a 25-foot lift or a 50-foot lift? So in this case, more than 25, we'll need the 50-foot lift. All right, your turn. The shadow of your tree is 50 feet. We don't know its height. The shadow of our stake that's 3 feet above the ground is 1.2 feet. Let's do some ratios here. 1.2 over 15 is be the same as 3 over x. So we're going to say 45 equals 1.2x. 45 divided by 1.2 is equal to 37.5 feet. All right, that'll do it. We'll see you in class.